Exponent properties. Okay, so far we've talked about exponents like this, and then maybe we wanted to substitute x equals 2, and so we had 2 squared, which was 4. You know that we've used exponents before. However, there are many more properties than these. Okay, in fact, they can get quite complicated. We're not going to touch all of them, but we're going to get a good idea of some of these. Like, what about a negative exponent? What about a zero exponent? Okay, later, not this class, you'll get fraction exponents. Those are kind of fun. Okay, let's see what this is all about. So exponents are used to express repeated multiplication. Okay, so if you multiply 2 3 times, you write it as 2 to the third power. Okay, that's one way of saying it. To the third. Okay, it's not 2 3 or 2 times 3. It's 2 to the third. The 3 is small and it is up high. It means something different. Okay, so the base is the 2. The exponent is the little tiny number that tells you how many 2's you have. Okay, so it tells you how many times the base is used as a factor. Factors are multiplying things together. Okay, so how many times do we multiply the base together? So 5 squared, the base is 5 and the exponent is 2. So that means I have two 5's multiplied together, or 25. Okay, 3 to the fourth means the base is 3 and the exponent is 4. So that means I have 4 3's multiplied together. Okay, so if you can't do that in your head, this is what you could do. Take 2 at a time. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. If you're using a calculator, you have multiple ways that it could be expressed in your buttons to understand how to do it. Okay, Canvas has you, if you're typing this, for example, and then you use a little caret, it's called one of those little up arrows, and then a 2. And I believe it automatically changes the format to look like this. Okay, but this caret you will see on your calculator as well. Okay, this means basically raise up the next number 2. So it's raising it up. Okay, it's like that is an arrow making it go up. Okay, another button you could see would be y to the x power. You could see an x squared. You could see x to the n. All kinds of different things, and you're just going to have to play with your computer calculator to see which one you have. Casios are different than TIs, which are all different than your phones, which, so just figure out which one you have. Okay, so for this version here, and you wanted to do 5 squared again, you would hit the 5 first, and then that button, and then the 2. Okay, for the next one, you would hit 5, and then that button, and it would automatically square it. This one, you would do 5, and then a 2, like that. Okay, so all kinds of different possibilities, and you just need to play around with it and see what happens. So you know that 5 times 5 is 25, right? Two 5's multiplied by themselves. So you can try this one, try 5 squared in your calculator, try 3 to the fourth in your calculator, and see if you get these two answers. Now here, when you're entering things in your calculator, sometimes your calculator will do order of operations and sometimes it won't. Okay, so what you can do to make absolutely certain that your calculator is providing the answer for the correct problem is actually type in the parentheses. Okay, there are parentheses buttons on your calculator and you can use them. And that would be absolutely certain to get it right. Okay, let me explain this though, because hopefully you won't need to rely on your calculator for every single computation, and this you can do by yourself. Okay, so the exponent affects only what it is immediately behind. Okay, so the base is the number that it's immediately behind. Okay, so this 2 is your exponent, and it's immediately behind the 3, right? Okay, so this 3 is your base. Notice the negative is not inseparably connected to the 3. Okay, so there are 2 3's and 1 negative. So that looks like this. Negative 3 times 3. Because this exponent tells me there are 2 3's, but this negative is going to come down because it's not squared. So the answer to this one is negative 9. Okay, now on this next one, the 2, the exponent, is immediately behind a parenthesis. Parentheses always come in pairs. So that means I have 2 sets of parentheses. And inside each of those parentheses is the negative 3 that we started with. Okay, so 3 times 3 is 9. Negative times negative is a positive. Okay, so parentheses make a big difference. Difference between these two is 18. It's not just the negative. Okay, so if you had negative $9 versus positive $9, there's $18 difference between the two of those. So if you miss a negative, it's not just a little thing most of the time. Okay, you need to understand these rules. Okay, next one. The exponent affects what it is immediately behind. So in this case, the parentheses don't affect anything related to the exponent. Okay, do they affect the rest of the problem? Okay, so this negative is going to come down. 3 squared, 2 3's, okay, are still inside those parentheses. So the negative is still going to come down. 3 times 3 is 9. So those parentheses really are not necessary. That problem here is basically this problem here. I could have put parentheses right here and it wouldn't have made a difference. Okay, last one. The exponent affects what it is immediately behind, parentheses, and there's always a pair. Okay, negative is not affected, so it comes down, and there are 2 sets of parentheses multiplied together, and each of them has a positive 3. So negative comes down again. 3 times 3 is 9. Okay, so please watch carefully, because if you're off by a negative, like I said before, it's not just barely off. It's quite a bit off. And if you have a more complicated problem and you make a mistake early, then you're going to make the whole problem a lot worse. Okay? All right, back to your actual notes. Okay, so here we go. Identify the base and the exponent and then evaluate. Base is the 3, exponent's the 4. You can see that. And we did this one on the other page anyway. So 4 3's multiplied together, and then you multiply them and you get 81. Okay, so evaluate. The 2 is immediately behind the parenthesis, so you can see they wrote the parentheses twice. A negative times a negative is a positive. This one, they wrote it this way. I'm going to write it a little bit differently. This is how we did it on the other page, is the negative just basically comes down, or in this case, over, and then there are 2 4's because the 2 is immediately behind the 4. So 2 4's Negative is not affected. So it's negative 16, just like they got. Now go ahead and try yours. Of course, yours are a little bit different, a little harder maybe. Fraction, some of you will hate that, so it's not that hard. Go ahead and pause it, try it, and come back. Okay, here we go. So the exponent, hang on, there, that's better. The exponent is immediately behind the parenthesis. So we need the entire set of parentheses 3 times. And each set of parentheses has a 2/3 in it. And I hope you guys are now doing your fractions horizontally, no diagonals, right? This is one reason for it right here. When you're multiplying, you multiply straight across. So 2 times 2 times 2, and 3 times 3 times 3. Okay? So basically, 2 times 2 times 2 looks like this, and 3 times 3 times 3 looks like this. This is going to be a rule that we get from this in a little while. Okay? Right now, I'm just going to do 2 times 2 is 4, 4 times 2 is 8, over 3 times 3 is 9, 9 times 3 is 27. There you go. Okay, the bottom one. The exponent is immediately behind the parenthesis, right? So we need 4 sets of parentheses. So there's 1, 2, 3, and 4. Okay, these two make a positive 4. These two make a positive 4. Positive 4 times positive 4 is positive 16. Okay, not too bad, I hope. Okay, so here's our first rule, the product rule of exponents. Okay, so the product rule is shown here, and every time they do rules, usually they use variables for everything so that they can be replaced by numbers of any kind. Okay, so that may not make too much. And if it doesn't make sense, maybe it will after I show you this one. Okay, it says practice. We're going to practice together. Okay, what y to the second power? Remember, second power you could say squared, and third power you could say cubed. Okay, so y to the second power looks like this, right? So this one is y times y. And now this one is y times y times y. And they're being times. So can you see how we can go backwards and now write this as y to the fifth, because there's 5 y's in that line right here. Okay, so how do I get from here to here? You basically add these two, right? Because 2 plus 3 is 5, and we got a 5. So when the bases are the same, the y and the y, and you're multiplying, then you add the exponents. Okay, and that's what this is saying. You multiply like bases means add the exponents. Okay, number 2 over here. So all of the bases are the same, x, x, x. So we're going to add the exponents. 2 plus 8 is 10 plus, if you don't see anything, it's a 1. You just don't write it. You don't want to have to write 1s everywhere you have a variable that doesn't have an exponent. It just gets crazy. So they just don't write it. So this becomes 2 plus 8 is 10, add 1 is 11. You're done. That's it. Okay, so when the bases are the same or alike, you just add the exponents. Okay? So over here, we have multiple things happening here, but we do have x's which are alike. So we're going to add their exponents. So that part becomes x to the ninth because we added 2 and 7. What do we do with the 3 and the 6? These are whole numbers like we've always done, and we're timesing them like we've always done. So it's 18. 18x to the ninth. You do not change the rules that you've learned for your entire life for multiplying. You don't all of a sudden add the 3 and the 6. Okay? These rules are for exponents only. Little tiny numbers that are raised up, not the great big numbers. Okay? All right, with that in mind, see if you can do this one on your own first. Okay, so we have the numbers in front. Negative 5 times 8 is negative 40. And remember, those are called the coefficients. It's the number in front of a variable, or in this case, multiple variables. It's a coefficient. So you multiply the coefficients and we get negative 40. Okay, now we have a squared and we have a cubed. So we're going to add those exponents and get a to the fifth. Then we have b to the first, right, because it's not printed, and b to the fourth. So 1 plus 4 is 5. So this is b to the fifth. Okay. All right. I think these are kind of fun. And now we have a new rule. Okay. So let me explain this one by doing it. Okay. So we have x cubed squared. All right. So what this means is the exponent affects what it is immediately behind, right? So that means I have two sets of parentheses, and each set of parentheses is going to have an x cubed in it. Okay, so we can use what we just learned, and we can recognize that the bases are the same. So we're going to add the exponents, and we get x to the sixth. Or you can recognize that this means 3x's times together, and so does this. And we are timesing those. Total of 6x's multiplied together. Okay, so when you have a power to a power, or an exponent raised to an exponent on the same base, you multiply these. Okay, and that's what this says right there. One base raised to two exponents, you multiply the exponent. Okay, so it's a power to a power. You have a power to a power, the power of a power, the power of a quotient. You know, it's all of these things. If you don't remember the names, that's fine. Just know how to do it. That's the important part. Okay, so these other two, let me give you examples of both of those. Okay, so let's say we had y, oh, let's start with x. X times y, and the whole thing is squared. That's this one. Two things in the parentheses multiplied together. Okay, so again, the exponent affects what it is immediately behind, right? So we have two sets of parentheses, and each one of them has x times y in it. Okay, remember, you don't need that dot. If you just had x, y, because they're shoved together with nothing in between, it means multiply. Okay, I'm writing it because they did. but you don't need it. And I'm not going to write it after this. Okay, let's keep going down here. Multiplying these now. So we have x times x gives me 2x's multiplied together, or x squared. And y times y means 2y's multiplied together, or y squared. You can put your dot in between if you want, and I did because they did, but again, you don't need it. Okay, so what you're doing here to get from the original to the answer without having to go through this middle step is this. Your exponent affects both parts of the inside. In other words, you're distributing the squared over the multiply. Okay? All right, let's look at the quotient. We'll do examples of all of these here in just a minute. Power of a quotient. I'm going to use actual numbers and then do variables. Okay, so what if I had 2/3 cubed? Look familiar? That's the one we did before that I said we're going to see again. Okay, so we basically said that the 3 affects what it's immediately behind. So we need 3 sets of parentheses, and in each set of parentheses is a 2/3. And then you're going to multiply straight across the top, and we got 8 over straight across the bottom, and we got 27. Okay, but this 3 gets distributed to both of those. So you have 2 cubed over 3 cubed. 1, 2, 3 twos, and 1, 2, 3 threes. There we go. Okay, if it's variables, it's easier. So if I have x over y and the whole thing to the fourth, you basically go x to the fourth over y to the fourth. You're done. There's no calculating to do. You just distribute the exponent over the divide. All right, here's a whole mess of practice problems. And there's some things in here we haven't seen yet, so see what you can do with them. Okay, see if you can break them down, do it yourself first. Okay, I know it's really hard to do that on your own, but it's really important that you try it first, okay? Okay, this one is the exponent or a power to a power rule. All you have to do is multiply those two together. So we get x to the 15th. Okay, that's what it actually means, right? 3 of these, and each of those is 5, 3, 4, 5 x's. So now I'm on this one. 1, 2, 3, 4, 5. Now I'm on this one. 1, 2, 3, 4, 5. And how many are there total? 15. Okay? So much easier to know the rule that you just times these two together and you get 15. Okay, number 2. Again, try it on your own if you haven't. Now this one's important to realize that this negative 4 is not affected by the 5. The exponent of 5 is immediately behind the parentheses, and these parentheses are not around the negative 4. Okay, so that means the negative 4 comes down, and now technically we have 5 of these, right? I wouldn't want to do that either, so I'm going to do the shortcut, which is the rule we just learned. You multiply those two. So I get y to the 15th. Now at this point, those parentheses are useless. So negative 4y to the 15th. Okay? They're useless because we don't have a negative. We're not adding anything. We're not subtracting anything. They just mean multiply. So because this means multiplying by the negative 4, I'm just going to get rid of them. If you put a dot here, it's not wrong. It's just not needed. Okay, number 3. This time, everything is affected by the 5, right? Because it's behind the parentheses. So rather than writing everything in the parentheses 5 times, I'm going to take the 5 to all 3 parts. Okay, so basically we would have 3 to the 5th. Don't write this. A squared to the 5th and b to the 4th to the 5th. I guess you can write it if you want to, but I wouldn't. I would know the rules and I would do them without writing it. Okay, 3 to the 5th you might need to look up, or you might need to put it in your calculator and figure it out. It is 243, because 2 times 2 times 2 times 2, or 3. Okay, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. Okay, or do it on your calculator, right? Okay, so these two, you're just going to multiply these two together. So 2 times 5 is 10. So this is going to be a to the 10th. And then b to the 4 times 5 is 20. And you're done. Okay, number 4. Again, the 3 is affecting everything because the parentheses are around everything. Okay, so this 3 is going to go to the negative 2, x cubed, y squared, and z. Okay, so this is a good place to remind you of something. An odd number of negatives, which we have here, is going to be a negative. Okay, these two make positive 4. This one has to come down. And positive times a negative is a negative. Okay, so an odd number, 1, 2, 3, gives you a negative. An even number, so like just the 2 was a positive. If I were to have one more, I would have a negative 2 with this negative 2, which would make that positive. Okay, so an even number of negatives means it's a positive. An odd number of negatives means it's a negative. Okay, this is something you probably have already known and maybe you just didn't ever see it written down, but that's a wonderful thing to remember. If this is odd and it's being used on a negative, then the answer will be negative. Okay? All right, so that tells me right there that I have a negative 2 cubed, which is 8. Now, x cubed cubed, so I'm going to do 3 times 3 is 9. And y to the 2 times 3 is 6. And then z, 1 times 3 is 3. And you're done. Again, I think these are fun. I know I'm weird. Okay, number 5. We're going to use the rule and distribute the squared to both of those. Okay, so we end up with, let me do them in different colors, and okay, so we're going to do this one and this one. So the orange or gold arrow becomes 4 times 2, so that's 8. So y to the 8th over purple arrow is 3 squared. Remember, it's multiply, so it's 9. Okay, if you have to show this, please do. I will not judge you at all. I want to see everything that you do. Okay, I want a messy paper. I don't want it pristinely clean. I want to see your process. If you use a calculator, that's fine too. But if you want to write it down, never erase it. Just always put it there. Be proud of it. Okay? All right, this one. That 4 on the outside is going to apply to all of the parts on the inside. So we're going to do 4 to the third on the top. Try that again. 3 to the fourth on the top. So 3 to the fourth. We did this in a previous problem. So this gives us 9. This gives us 9. 9 times 9 is 81. So we have 81 right there. Now, multiplying here, x cubed to the fourth. We're timesing these two, right? So that's x to the 12th. Okay, so this is what we have technically, and then we can just 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. Okay, hopefully you don't have to do that, but I'm just showing you because it's there. Okay, so now I'm going to do yellow again, or gold, orange, whatever that color is, because it's a coefficient. Okay, so 2 to the fourth means this. So 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. Okay, so 16 is down here. And now a power to a power, you're just going to multiply the exponents. And you're done. Okay, if this fraction, 3 halves, cannot simplify, then this fraction won't simplify either. Okay, so don't worry about trying to simplify it afterwards. How did you do? Hopefully okay. These look kind of complicated, but they're not. Every single individual step is easy. You're multiplying, you're adding. That's about it, okay? All right, new rule called the quotient rule. Quotient means divide, okay? So we're doing divide. Let me explain it. Here we go. X to the fifth over x squared. So x to the fifth over x squared. This means we have 5 of them on the top multiplied together, and 5x's on the 2x's on the bottom multiplied together. Okay? Anytime you have something on the top and something on the bottom that are identical, they cancel. So we can get rid of this x and this x, and we're left with those. So the answer is x cubed. Okay? How do I get that from my original? You subtract these two. Okay? What I generally say is the 2 on the bottom cancel 2 on the top and leave you with 3. Okay? 2 on the bottom cancel with 2 on the top and leave you with 3. Okay? So another one. N to the 10th over n to the 4th. Okay? So the 4 on the bottom cancel with 4 on the top. So that means 10 minus 4 is 6. Okay, if the problem gets more complicated, I will literally write it. These 4 cancel these 4, and they leave me with 6. And then I keep going with the rest of the problem. Okay? All right, and then you can see here that they subtracted. Okay? Like bases, you subtract the exponents. So if this was an n and this was a w, you couldn't do it. X, y, you couldn't do it. But because they're both x, because they're both n, this works. And here's what it looks like in more complicated problems. So see what you can do with it and then come back. All right, here we go. So, like I said before, these 5 cancel with 5 of these and leave you with 3, right? Okay, that's what it looks like. And cancel, 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 cancel. There are 3 left. And that's what we got. Okay, you can't just leave it that way, floating up at the top of the fraction. You have to rewrite it as t cubed. Okay, if the denominator cancels, technically it's a 1, but you never write a 1 denominator, correct? So there we are. All right, this one. How many do we have on the bottom? We just have 1, right? If they don't print it, it's 1. So the 1 in the bottom cancels 1 on the top, or in other words, this one cancels with one of those and leaves you with 9. Okay, notice that my A's and my 9's look incredibly similar. Be careful with yours as well. Okay, if you want to, I can't even do it. If you want to do your A's like this and your 9's like that, so it makes, I hate writing A's like that. Yeah, just make certain you can read it. Leave a longer tail on your 9 or something. Okay, number 3. I'm going to do one at a time. So starting with the 5 and the 2, I can't do anything. So I am going to leave them as 5 on the top, 2 on the bottom. That fraction line might be way too big. I don't know. I don't care. Okay. So now I'm going to look at a to the third and a. The 1a on the bottom cancels with 1a on the top. Whoops. So this 1 cancels with one of those and leaves me with 2. The b's. These 2 cancel with 2 of those and leave me with 3. The 1c on the bottom cancels with one of those 2 and leaves me with 1. And again, if you write the 1, it's not wrong. It's just not needed. Okay, so then I just rewrite over here what I have left. And there you go. Okay, that 2 on the bottom can be anywhere. It can be right in the middle if you want to. Doesn't matter, just as long as it's in the denominator. Okay, number 4. This time there is something I can do with the 6 and the 8. Okay, they both divide by 2, right? So this is how you look at it, breaking it down. So this ends up being negative 3/4. The way I do it is I look at the 6 and the 8. They both divide by 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. And just to be safe, I take that negative up with the 3 because I don't want to forget it. Okay, now on the u, this one u cancels with one of those and leaves me with 2. These two v's cancel with 2 of those and leave me with 2. So rewriting what I have left, the top is a negative 3u squared v squared, and the bottom is just the 4. Okay, so hopefully you did okay. Just take it one step at a time and be very careful, okay? Negative exponents. Yes, they exist. I know, it's like, oh, all right. So I'm going to write the problem down and then show you multiple ways of doing it. and how they came up with what they came up with. Okay, so what this technically means is 2x's on the top, 5x's multiplied on the bottom, and cancels, cancels. We don't have anything left on the top, but we have 3 on the bottom. Okay, so that leaves us with 3 on the bottom. And, okay, technically, when you cross these out, there's a 1 here and here. There's a 1 here and here. You just don't write the ones, right? So now I need to, though, because I can't leave the top of a fraction blank. So it's basically a placeholder. Okay? All right, so the answer to this problem, because of all of this, is 1 over x cubed. Okay? So basically, these two x's cancel with 2 of these, leaving you with 3 on the bottom, because that's where the remainder is. Okay? All right, now, using the rule that we've done before with subtract, if I have a fraction with the same base, we're going to subtract the exponents, which means negative 3. 5 or 2 minus 5 is negative 3. So that means that this answer and this answer have to be the same because it was the same problem worked out 2 different ways. Okay, so that gives us the rule. A variable to a negative power, any negative power, negative 2, negative 7, negative 93, whatever, negative n, I'll just say, any number is equal to 1 over x to that power. So the negative moves it downstairs and becomes positive. Okay? And they said it, they chose a different letter. That's okay. I had N and they chose M. Doesn't matter. The idea is when you have a negative exponent, it has to change floors. Okay? If it's on the top floor, it has to go to the bottom. Let's try a couple. I have no idea why I didn't copy problems 1 and 2 over, but they're there. Okay, see if you can do all 6 of those. There are a couple, like this one we haven't really gone over, but logic might be able to make you see how that works. And same thing with this one. Okay, see what you can do. All right, let's take a look at number 1. So all we have is a single variable to a negative power. If it's a single term like this, it's always over 1. It's always a whole number. So it's in the numerator. It's upstairs. So my answer means I need to move it downstairs and make it positive. When it changes over the fraction line, okay, so the fraction line was here, but this means the whole thing has got to go down, which I did. As soon as it goes over the fraction line, it changes to a positive. Okay, and now I need a 1 up here. Okay, you can think of that as the coefficient of the x that we just didn't write. But when the x moves, the coefficient has to show up. So it's a 1. 1 over x to the 6th. Okay, number 2. Again, this is over a 1. It's a whole number. So when I rewrite it, I'm going to take this whole thing and move it down and make it a positive exponent. The 1 has to show up to make it make sense, to make a placeholder, whatever you want to say. And we get 1 over 6 squared, which is 36. Okay, number 3. This exponent, the negative 4, only is on the x. The 3 is not affected. Okay, so that looks like this. The 3 stays on the top, okay, because this is like the whole thing over 1. But now this has to go down. So this becomes x to the 4th downstairs. 3 stays because it isn't affected by the negative 4 exponent. Okay, number 4. Remember I said that it has to change floors, right? So this is downstairs and it's negative. So now it needs to move upstairs. And because it crosses the fraction line, it has to change signs and it becomes positive. Okay, so that looks like this. Okay, there's your upstairs and downstairs, right? So because this was downstairs, it's going to move upstairs. So now it is x to the 5th. That 1 can stay there. And now what's left on the bottom? A 1. We don't need this 1 because fraction with a denominator of 1, it's never needed. And we don't need this coefficient 1 because that's also never needed. Your answer is just x to the 5th. Okay, number 5. If you have a negative exponent, you need to change floors in your fraction. So this one needs to go downstairs and this one needs to go upstairs. Okay, so that looks like this. This one's going to go down and this one is going to go up. And when they change past, or they move past the fraction bar, they change to positive. So y cubed is now on the top, and next to the positive 6th is now on the bottom. And that's your answer. You can't do anything. Okay, number 6. This one gets crazy unless you know the one trick that we talked about earlier. Okay, so that means this whole thing has to go downstairs. So does it look like this? 1 over 1/2 to the positive 2nd? That's just crazy, but that's true. It works, and you could continue doing that. And that's what it would look like if you did every single step. But the answer is 4 doing all of that. Okay, so now let's go back and do a shortcut. And no, you don't need to know how to do all of that I just erased. I just hurried and whipped it out so that you could see that it can be done. Okay, so the shortcut is, if you remember, this has to go to both of them, right? So this means 1 to the negative 2nd over 2 to the negative 2nd. This is negative upstairs, so it needs to go downstairs. This is negative exponent downstairs, so it needs to go upstairs. So we end up with 2 to the positive 2nd on the top and 1 to the positive 2nd on the bottom, which is 4 over 1, which is 4. Much easier. Okay, how did you do? Hopefully, okay. Some of those were a little tricky considering what we'd already done, but hopefully you got them and hopefully you understand them now if you didn't get them. Okay, number 6, the one that we did right here, the 1/2, leads us to another rule on the other page, and I'm going to show you here in just a second. Okay, but right now, let's take a look at this. What we're going to do is go from here basically to kind of here. What this one really is 2 over 1 squared. Because if I took this and went like that, I would get this. Okay, so basically, you take the 1 over 2 and you flip it to 2 over 1 and change the sign of the exponent. Okay, now let's go back to that other page. Okay, so a over b, now it's b over a. It was a negative exponent, now it's a positive exponent. That's the trick. And there are no examples of this one, so let me do one for you. Okay, so we have a fraction inside the parentheses, and then the entire fraction is raised to a negative exponent. So what you do is flip the fraction over. So y cubed over x squared, and now it's to the positive fourth. That one goes here and here, so we get y to the 12th over x to the 8th. And you're done. Okay? A way of proving this, I'm going to do exactly the same problem and show you how it can be done without using this new rule. Okay, so we're going to take the negative 4 exponent to both, and we end up with x to the negative 8th over y to the negative 12th. This is negative in the numerator, or the exponent is, so it needs to go downstairs. This is negative in the denominator, so it needs to go upstairs. Every time it crosses the fraction bar, it changes to the opposite sign of the exponent. So we get y to the 12th on the top and x to the 8th on the bottom, which is exactly what we got before. Whichever one you feel more comfortable with is the one that you should do. They both work. Okay, zero exponents. Okay, let me explain what all of this does by doing it again. And I'm going to use n's just because. So n to the fourth over n to the fourth. What does that mean? Okay, this means we have 4 n's on the top, 4 n's on the bottom. These cancel, leaving you a 1. These cancel, leaving you a 1, a 1, and a 1. Technically, they're on the bottom as well. So 1 times 1 times 1 times 1 over 1 times 1 times 1 times 1, which is 1. That's one way of looking at it. Okay, another way of looking at it is the coefficient of both of these are 1s. We just don't write them. Okay, but now these 4 cancel with those 4 and leave nothing for either one of them. So the answer is 1 over 1, which is 1. Okay, either way, something over itself, no matter what that something is going to equal 1. Okay, now, using the rule that we learned before, we can subtract exponents. So 4 minus 4 is 0. Since this is the same problem as this, that means these have to be the same. In other words, n to the 0 power is 1. Okay? And that's how they did it as well. It's just harder to read it and make sense out of it. Okay? Let me show you with numbers really fast. Okay? So 2 to the 4th, for example, is 2 times 2 times 2 times 2, right? And 2 times 2 is 4, times 2 is 8, times 2 is 16. All right, 2 to the 3rd. So means, hang on just a minute. Math is all about patterns. So I'm going to try to find the pattern here and then complete the pattern as I go down, and you'll see what's happening. So 2 times 2 is 4, times 2 is 8. All right, so far, what I've done is subtracted 1 on the exponent. And what that does over here on the end is I divide by 2. 16 divided by 2 is 8. And the reason that works is because this had 4 2's, this only has 3, so I got rid of 1. By getting rid of 1, I divide by it. Okay? So if I continue that same pattern, subtract 1 on the exponent means divide by 2 over here. Okay, I would have 2 to the second, which is 2 times 2, which is 4. And it did work. I divided by 2, right? Okay, let's do it again. 2 to the first power is equal to just 1 2, which means I divided by 2 again, and it worked. Let's do another one. What comes after 1? 0. So over on this side, I need to divide by 2. What's 2 divided by 2? 1. So 2 to the 0 power, 2 to the 0 power is 1. Just because, let's keep going over here. Go one more step. 2 to the negative 1 power, right? If I'm subtracting 1. So down 1, down 1, down 1, down 1, down 1. Now, my pattern says I have to divide by 2. What is 1 divided by 2? 1/2. So that also explains negative exponents. Okay, I could keep going. What's half of a half? 1/4, which basically is 1 over 2 squared. Go again. What's half of a fourth? 1/8, which is basically 2 cubed. Okay, so this shows that a negative exponent in the numerator goes to the denominator and becomes a positive exponent. So this is kind of cool. Okay, let's try some actual problems. Here we go. Okay, remember, anything to the 0 power is 1. However, if there's another anything, then this orange 0 only affects the n. M doesn't have the orange 0. Okay, so it's not equal to 1. It is now equal to m. Okay, so be really careful. So here we go. 16, one thing to the 0 power, that will be 1. Number 2, one thing to the 0 power, that will also be 1. It doesn't matter what that thing is. It can be a number, it can be a variable, or it can be a whole bunch of things. Okay? This 0 is right behind the parenthesis. So that means they come in pairs, and everything inside the parentheses is taken to the 0 power, which means 1. Okay, kind of cool, huh? Okay, over here. 3 times x to the 0. That's like this. The x is to the 0 power, so this is equal to 1, but the 3 stays. So this is 3. Okay, let me do another one of those. Well, actually, that's finished, and then I'll do another one at the bottom. Okay, and that's just to remind me. Okay, so here the 0, the exponent, is immediately behind the parentheses. So that means everything in the parentheses is to the 0 power. The negative is not affected. It comes down. And everything in the parentheses to the 0 power means 1. So this is negative 1. Okay, number 6. 0 is immediately behind the parenthesis. So, because they come in pairs, everything inside the parentheses is to the 0 power. That whole mess is equal to 1. Okay, let me give you another one. Okay, what about this? The 0 is on the x. It's an exponent on the x. So that means only the x turns to a 1. So technically what we have is negative 3 times 1 times y cubed, which is negative 3y cubed. Okay, so at the beginning, this is what I do. I just cross the whole thing out and put a 1. Then I figure out the rest. So negative 3 times 1, and then the y cubed. Let's do another one of those. Made it one step harder because I could. Okay, so I see a 0 exponent. It's on the b, which means b is a 1. I also see a negative exponent, which means that has to go downstairs. In other words, I need to make this into a fraction. Okay, so we get 4 stays, a squared stays, b disappeared, and now c goes down, whoops, to the denominator, but it changes the sign of the exponent when it does it. And you're done. That's it. Okay, because there are not too many examples, I gave you 2 more. There we go. So go ahead and try them. All right, so the first one, y to the 0 is 1, right? Which means you're left with the negative 5, the x squared, and the z cubed. And that's it. Okay, now be really careful. This is just a negative 5. It's not a 5 to a negative exponent, so it doesn't need to move anywhere. It's just a negative 5. So this is your answer. Okay, on the next one, here's your 0, and it's immediately behind the parentheses. So that means everything in the parentheses turns to 1. Okay, so we end up with negative 3n squared over negative 1. This negative is that negative. Okay, the two negatives cancel each other out. So we are left with 3n squared over 1, which means you don't need it. It's just 3n squared. Okay, so we had quite a few different rules. And, whoops, they are not absolutely necessary. They just make life a little bit easier for you. Okay, so I'm never going to ask you what the quotient rule of exponent is. Okay, you just need to know how to use it. Okay, this is incredibly important right there. Don't forget that part. Okay, power of a product, power of a quotient, power of a power, product rule, all of these, just know how to use them. Okay, you are done. Good luck. You got this. Send me questions if you have.